Hello guys, welcome back to the Advanced Golang Essentials. This course is designed to equip you with everything you need to become a strong Golang engineer. And in this course, we are going to tackle most of the essential topics and reinforce them with practical example. Let's start by Struct. So my screen is over here and the camera is over here. So you should know that a struct is just bundling data. If you come from a programming language like, let me say JavaScript, you know that if you define a struct person, you will have you will eventually have attributes like name, ID, email, and other attributes as many as you want. So how do we accomplish that in Golang? We define a struct. And a struct is just a type that's gonna have multiple attributes, or it can be a concrete type. So it depends on you. So what am I gonna start with? In Golang, when you start creating a struct, you have to pay attention to three stuff. The first is the first two keyword. If you see here, I have a type keyword, and then I have the name of my type, and then I have a struct keyword. So after that, I've opened my curly braces and added all my attributes in here. It means this struct is gonna be referred to as user, and it has all of these multiple attributes bundled to A. So this is simply how you define a struct in Golang. And how can you declare this struct? You can declare a user and now assign values to these to the fields of this struct. So how can you do that? There is a simple way to accomplish that without back and forth. So as you can see right now, we have already assigned values to our fields. How did we do this? And first of all, you'll find out that there is this no conversion because we don't have the var keyword and then this variable name and then the type. Why? Because this does direct infer, like it infers the type of the value to the variable name. And this eliminates the pain of writing var and putting here a type. So because by just doing this, it's gonna just get a type. Because if you hover over this, you'll find out that this is a var user, and user is the type. So I guess you get the points at this stage. Now, what can we do with this struct? We can print the values of it, and we can also access values of this struct. Very simply, we can just use FMT, the package, to print this. And we can accomplish that by doing this. This is how you print the values. And this is how you access a value from a struct by a dot operator. Now, if we go back to this and go ahead and print, you will find out that we can see our value displayed over here and the accessed field that we just read from our struct. So why did we do this? We just wanted you to know why do you have a struct and how you can define it in Golang and assign values to this struct by declaring a variable u and doing all of these, and then how can you access field or read field from our struct. That's simply it. But also, if you don't assign any values to our struct, what's going to happen is fields will take the default values, and that can be accomplished using just these to demonstrate that. And if we print, you'll find out that our value right now, our values, the values of our fields are defaults. We have for integer 0, for string, empty string, and for boolean false. So that's just something you should keep in mind. Moving forward, we're going to tackle lesson 2, and this is going to be about pointers. Understanding pointers is key because it appears everywhere in Golang. So, in this function, we are going to cover the pillars of pointers. And this is going to be the three operators that will always do the work. So, moving here, you will see my comments here highlighting a simple detail. It's like a summary of what they are and how they operate. First of all, you should keep this in your mind. You have to know that if you have a sign, this sign in front of any variable name, that simply means the address of that variable name. Very simple. And if you go ahead and have a an asterisk in front of a type, it means in type or a pointer to that type. So, and if you have down here something like an asterisk in front of a variable name, because this was in front of a type, it means a pointer to that type. In front of a variable name, it means on a pointer or the value of p points at. So the value of p points at, it points at a pointer, and a pointer is just an address. So I'm just insisting or emphasizing on these three operators because you're going to be using them more often than you think. So let's move down here to this last operator. I said an asterisk in front of a variable name, it is on a pointer, and it simply means a value of p points at. And this can also be called dereference. When you dereference a value, you can read or write through it. So it's that simple. And I'm gonna provide you with practical example to understand this before we even implement it in the counter, so you can have a great understanding and great foundation of how they do work. So below here in my function, my main function, I will create a variable x and I'll assign to e a value 42, and then a variable p and assign to e a pointer to x, which means the address of x. And whenever I print this p, guess what it's gonna return? The address of x, because that's what we assigned to e. And if you hover on this, you will see that this is a pointer to this value. Just put this in your mind, because when we scroll back up, you'll understand that this means a pointer to t. When you pass an asterisk in front of a type, it means a pointer to t. And the example was here. So now when you scroll down here, what I want you to put in your mind is when you hover over p is a pointer to integer. This simply means we are getting a pointer to this pointer, and this is going to give us the address. All right, the pointer the pointer to this pointer is going to give us the address. If we print, it's going to give us, sorry, the pointer to a pointer is going to give us the value. But if we go here, we come here and put it here and get rid of this and now put this, we are gonna get the address over there. So I was just trying to show you that so you understand what are we doing. If you hover, you'll see var and it points to this type. And if you print this p itself, it's gonna give you the address because that's what we are storing here. But if you dereference the p, it's gonna read the value at that address. And this is what we said. Value value p points at. So value p at this time points at this address. We're gonna get the value at this address, and that's what we're going to print in our terminal. So I'm gonna run the program, and as you can see, we have printed these. For the first time, we had the address. Secondly, we had the value 42, which is the value of x. After updating this value, because we can write through the pointer, and that's what we said here, right? Whenever you pass the asterisk in front of a variable, that simply means on that pointer, we can get the value at that pointer, or we can update the value at that pointer. That's what this means. And this is what we are doing here. We are updating the value at this pointer, and we are going to get what? We are going to get 100 on it, which means x is going to be updated. Because as you know very well, this is a pointer to what? To x, and it's actually the address. So the address, the value at that address must be updated to 100. Let's run that, and the last value should be 100. Great. Now you have you just understood the necessary things about memory and values. Now I'm going to challenge it by adding a counter, and we're going to have a by value and a by counter. So these are two functions that we are going to create. One is going to parse the counter as a value, and the other is going to pass the counter as an address. So if you pass the counter as an address, as a value, we are just passing the copy of that value. So I will scroll up and put it in this function. And as you can see, right now, we don't have even a counter. So I should start by defining a counter. So we have a counter right here, which is our struct. And then we are passing that struct in here. So I don't want you to look at this right now. I want you to just think. We are passing a struct, a counter struct. This can be an integer, right? We are passing this integer in here, and we are updating it. So this simply means that integer will be updated what's in only this scope. The mutation is in this local scope only, not out of it. So let me prove that by printing the output, because that's what's gonna bring more clarity. So I'll scroll down over here and I'll print this. You can see that I have already created a variable c, which is the counter, and I've assigned to my field variable 0. The field is n itself, and I've added this copy here, right? This is a copy. This is not a pointer. This is not going to access the memory. It means we are just passing here 0, actually. And if we have here 0, if we have n equals to 0, whenever we upgrade n in here, it's not going to affect this. Let's prove. See, n has not been affected. I'll actually print that so you can see. N remains untouched, and it's going to stay 0. N remains untouched. It's 0. Why? Because we passed the copy. How do we know? This by value did not have any pointers. It means it did not point to the memory. And when we are printing this n, we are now printing it in this function, in the value function. It means we are printing it globally, and it shouldn't change. This value here shouldn't change because it was just passed here. And whatever has been passed, whatever happened in here without any pointers did not change anything or any values. So I'll scroll a little bit down and now use a by pointer function. Now I'll come back at the top and I'll place this. Just, you can see the difference between the both of these is just this asterisk. So at this point, we are dealing with the address. We are dealing with the pointer to this address. Why? Because we are assuming in our head that we're going to get the address of this type. So if we go down here, what can we do? We can just pass the same counter in here, and as we are passing the pointer, so one thing to put in your head and note down is whenever we have a function that has a parameter of type pointer to a type, pointer of counter, and counter is a type, that simply means if we pass an argument, that argument must be an address, because we trying to mutate value on the caller. That simply means here, whenever we call something here in main, it should update the value of n, which was 0, and it's gonna now be 99. So let's go ahead and print this by executing our program, and it's now 99. So this simply explains that, and we shouldn't actually think back and forth. We have to understand when we pass a pointer and when we pass a value. So that closes everything about lesson 2. So we are going to move to lesson 3, which is going to be an order. So at this point, we are also to parse again a struct pointer, or a struct argument as a pointer. And this is going to be implementing a real world example of applied this account. So we are going to pass an order and a percentage of this account, and this is going to apply this account to that order, and then it will return us it will return us that order already disaccounted, if that makes sense. So I will go ahead and create my order struct at the top over here. After creating my order struct, I'll create my function, and this function will take the order struct as a pointer, because we are trying to modify the total of that order, because as you can see, we have the ID, total, and paid. So what we have to modify is the total of it. So we want this order to send the information to the payment system with the discount already applied to it. So what are we going to do here is we are going to pass the pointer and we are going to put the percentage. Looking at the fact that we have access to the memory, to the address, we are going to modify this total by applying the percentage and keep this false. So after doing this, what we can do is creating a pointer, creating an order, and applying the discount in our main. So I will do this and do this. And at this point, oh Lord, at this point we should be good to go. And I will come here and import fmt. So at this point we should be good to go, because we have created the order, we have applied the discount, we have created our order and updated the field which is at 10,000. And now that the percentage is 15, it should detect the 15 whenever we print it, because this order is gonna apply changes. So this caller, the caller functions must mutate. That's mutate the value of the struct whenever we call this function. So that's what this simply means. And remember, we are passing the address. It means we are going to receive the address and modify it. And after modifying it, it means this struct is going to be updated. The caller struct is going to be updated. So we go ahead and run that. And this is going to be in lesson 3. And if we run this, you will see that the order is now disaccounted. This is very simple math if you think of it, and memory access pattern, which we already discussed. When you know that you are passing, if you're passing this address and passing in the helper function, passing a parameter, having a parameter of type pointer to a certain type, If we pass that address of those, we pass the address of a certain order or a certain variable of that type, that simply means we can manipulate its data. So it means these colors struct is going to be affected. And that's why when we place here the order, it had been affected because we had its address here being manipulated at apply this account. So I hope this makes sense. And we are going to move now to lesson number 4.